This is the fourth lecture on Unit 1 covering error. So with this lecture, you're going to be able to distinguish between avoidable and unavoidable error, to identify sources of unavoidable experimental error, and to be able to calculate the percentage error in data. So you might want a calculator handy for that last one. So error in experiments can come from a variety of sources. A lot of times when we talk about error, we're thinking of human error. But human error is the type of error that's avoidable. So we can avoid making mistakes if we're careful enough. So some examples of human error include reading instruments wrong, making mistakes in calculations, doing the procedures wrong, writing things down wrong. We can avoid all four of those things just by reading things closer, making sure we understand the directions better, having people double check our calculations or our measurements, things like that. That will help us avoid error. But there's another type of error in science called unavoidable error, and that's error that cannot be avoided. So these things happen whether you like it or not, and you can't reduce it by being more careful or attentive to the experiment, or by having people double check you. So in almost every experiment using quantitative measurements, those are measurements with a number and a unit, unavoidable error is caused by a lack of precision in the instrument or measuring tools. So error can be reduced but never eliminated by using a more precise tool. So for example, if you're using a beaker to measure a liquid versus a graduated cylinder to measure a liquid, okay, one of those is more accurate than the other. One lacks precision more than the other. So to get a better read, you would probably want to use the graduated cylinder, and that's because it has more precision than the beaker. Now, when we do error, we do want to make a calculation about it, and so there's some terms that go with it. First is accepted value. That's the correct value based on reliable sources. So that's the so-called right answer, okay? And the way they get that is many scientists over many years have done a lot of experiments, and they've decided that to the best of their knowledge, this is the right value. The second value is the experimental value, and that's the value measured in the lab. So the experimental value is what you get when you do an experiment. And then when you subtract the difference between the accepted value and the experimental value, that is what we call the error. Okay, so that's your error. So difference right there, the word difference tells us that this is going to be a subtraction. Now on your notes here, you're missing these little absolute value lines right there. So you need to draw those in. So what I was just saying is the error is the experimental value minus the accepted value. Except for we get to take the absolute value of it. And that means that if it comes out to be a negative, we're going to make it a positive. So it doesn't matter if I do accepted value minus experimental value, because again, even if I get a negative number, it's going to be positive with those absolute value signs. So when we do the percent error, we take that error and we divide it by what we should have gotten, and then we multiply it by 100. Now, on your notes it has the percent, and that's okay. The percent is the units. So one mistake I've seen people do is they take that 100% and they change it to a decimal, which is a 1. Don't do that. Really multiply your value by 100. Okay, so let's try a problem here. Suppose you use a thermometer to measure the boiling point of pure water at standard atmospheric pressure. The thermometer reads 99.1 degrees Celsius. You know the accepted value for the boiling point of water is 100 degrees Celsius. What is the percent error? So here's my accepted value. Here's my experimental value then. So to get my error, I want to do the absolute value of the accepted minus this experimental value. Again, it doesn't matter what order we do it in because it's the absolute value. Oops, 99.1. So do that and I get 0.9 degrees Celsius. That's my error. So I can take that 0.9 degrees Celsius and I divide it by my accepted value. Well, my accepted value is 100 degrees Celsius, and then I get to take that and multiply it by 100. So if you didn't have a calculator, you can see that these two numbers actually cancel out, and I'm left with 0.9%. Now, these two numbers don't always cancel out. It just so happens that my accepted value here was 100. This number is going to change. Okay, it's going to change depending on the problem. This number right here will always be 100, always. Okay, so that was confusing to a few people in this problem. So there is my percent error. That is my answer. Okay. This worksheet that you have is a little bit different than the last. You have a couple of math problems to do on it. And with that, you do the work on a whiteboard or a sheet of paper and insert your work using the webcam. If it's a page full of math, like it will be in the future, I would give that to you on paper. But when it's just a couple of problems like this, I'll have you insert them into your electronic worksheet using a webcam. My parting thought here is science. If you don't make mistakes, you're doing it wrong. If you don't correct those mistakes, you're really doing it wrong. And if you can't accept you're mistaken, you're not doing it at all. So remember, science changes, people make mistakes. We got to just learn to work with it.